All right, now let's talk about some ionic bonding. So ionic bonding is one type of the two types we're going to talk about. We're going to talk about ionic and covalent. So this video is just for ionic bonding to help maybe clear up some stuff when you were looking at the notes prior. But ionic bonding is in between a metal and a non-metal. So remember, the metals are more on the left-hand side of your periodic table, and the non-metals are more on the right-hand side. So remember, if you were coloring your periodic table from Unit 2, the metals should have been colored yellow, and the non-metals are colored orange. So it's between a yellow and an orange, or a metal and a non-metal. The metals lose electrons, and the non-metals gain electron, aka the metals are positive charges and the nonmetals are negative charge. So it's a positive and a negative because we've all heard the saying that opposites attract. So the big deal thing here, you guys, is that ionic bonding electrons are transferred, okay? So I would really like you to remember that ionic bonding is between metal and a nonmetal and that electrons are transferred. That's what you should be kind of focusing on for right now. All right, so there's different naming rules for writing formulas. We're going to talk about writing formulas and we're going to talk about naming. So when we're writing formulas for ionic compounds, the positive ion, aka the metal, goes first, and the negative ion, or the nonmetal symbol, goes second. That's just the rule that we have, okay? So what you do is we write the symbols and the charges, then we balance the charges. You write how many of each atom you need as a subscript. So as a subscript, if you don't remember what that is, a subscript would be, like if that's your number, it's down here. It's this little N. That's a subscript, okay? Like a submarine. So that's a subscript. If you had something like this, now that N is called a superscript, and that's not what you want. You don't want numbers right next to your letters big. You want them kind of down below as a subscript. And as a final rule, again, there should not be charges in our final formula, okay? So again, we just need to be balancing our charges. So I'll give you some examples. So examples are aluminum chloride. So I'll do this one in blue. Aluminum, if we look at our periodic table, is Al. Chloride is chlorine, and it's Cl. Okay, because we'll talk about naming here in a little bit, and the names off the periodic table change from their ending to an IDE. So chlorine and chloride are the same thing, okay? So now here, aluminum, if I look at my periodic table that we already wrote our charges on, it has a charge of +3, and you do not have to have these charges memorized. You can have the charges written on your periodic table. Chlorine has a charge of -1, okay, and that was again from my periodic table. Now, if I'm balancing out those charges, I need to come up with the lowest common multiple. How do I make those balance out? So what is the lowest common multiple between 3 and 1? And if you think about it for a second, you'll figure out, oh, it's 3. 3 goes into 3 and 1 goes into 3. So aluminum, I only need one of them because it takes one aluminum to get to a +3 charge. I don't ever write a 1 as a superscript, so I'm not going to do that. That is not what I want to do, okay? So I'm going to erase that. That is not what we're writing. You never write 1. There's an invisible 1. So an invisible 1 for aluminum, okay? Now chlorine, remember our lowest common multiple is 3. How many chlorines do I need to get to 3? If each chlorine is a -1, I need 3 of them. So I'm going to need 3 chlorines. Okay, so now we have a +3 over here and a -3 over here, and it cancels out. Now I'll do the next one in a different color. Magnesium is Mg. It is in group number 2, so it's a +2 charge. And notice that I'm putting the charges way up top by my name so that it doesn't look like it's part of my formula, okay? Because I should never have a charge in my formula. Oxide is oxygen, and that has a -2 charge. And it's an O. Now I have to balance out those charges, but hey, look, this is so cool. +2 and -2, they already cancel out. So I'm good. I don't have to do anything there. MgO is the proper formula. Because remember, I'm not going to write the ones. Now I'll do calcium nitride. Calcium is in group number 2 again. It's +2. It's a Ca. Nitride is nitrogen. Okay, and that's a 3 charge, because that's what my periodic table told me. Again, I'm just finding where they are in the periodic table and looking up at the top of the groups. And remember, we wrote the charges up above on our periodic table. Nitrogen has an N as its symbol. So now, +2, -3. What's the lowest common multiple of 2 and 3? And you'll figure that out to be 6. 2 goes into 6 and 3 goes into 6. Okay? So how many 2's do we need to get to 6? And you need 3 2's, because 2 plus 2 plus 2 is 6. How many 3's do I need to get to 6? You need 2 of them. So now, calcium, 3 calciums gives me a positive 6, excuse me. 2 nitrogens gives me a -6. So they cancel out. You're good. That is the proper formula for it. There's no charges in my final formula. Okay? So let's talk about naming some ionic compounds, okay? So naming is the same sort of thing. We always name the positive ion or the metal first and the non-metal or the negative ion second. That metal, that positive ion, the name is right off the periodic table. It does not change, just like you were seeing before in those previous examples. Now that second name, that non-metal name, the root changes to IDE. Okay, so for example, F on the periodic table, it's a halogen, it's a -1 charge. It is called fluoride. It is not fluorine, because fluorine is the fluorine atom. It has no charge. Fluoride is the ion with the -1 charge. Oxygen turns into oxide when it becomes an ion. Okay, so you take off the J and you put an IDE. So every ionic compound has an IDE at the end of it. So here we go. Let's try this out. Ca right here is calcium. It's a metal, so I do not change the name. Cl is chlorine. That changes to chloride. Notice that there is a 2 right here. I am not putting any numbers in here. I do not put a number right there. That is not what I want to do. Yes, there is a 2 in the formula, but you are not putting a 2 at the end, okay? It's just calcium chloride. Bingo. BeO. Be is beryllium. O is oxygen. Remember, oxygen changes to oxide. Mg is magnesium. Nitrogen is N is nitrogen, but that changes to nitride. I know it's a little weird for now, but you just have to kind of trust that it'll get used to it. And notice, none of my names have, all of them have a first and a last name, a metal and a non-metal. There's no middle names. There's only 2 words for each one, and none of them have any numbers in it, okay? So I'll put this one up on the Google Classroom for you to try, but what you're going to want to do is lithium is a +1, barium is a +2, aluminum is a +3. Everything on this side right here is your positive. Everything up top is your negative. Nitrogen is a -3, O is a -2. So now what you're doing is you're just filling in the chart, and I will post this worksheet for you to try, and I'll post the key for you to try as well. But here with lithium right here and chlorine going down, if I'm going to do lithium and chlorine and fill in that box, lithium goes first because it's the positive, chlorine goes second. It's a positive one and a negative one, so it cancels out. Now if I go right next door to right here, lithium's a +1. That goes first. Nitrogen is a -3. Lowest common multiple between 1 and 3 is 3. You need 3 1s to get the 3. You only need 1 nitrogen, 1 3. And remember, that gets an invisible one, so I don't do anything there. Let's do this one as well as a kind of a last example with calcium and nitrogen. Calcium would go first. Nitrogen would go second. It's a +2 and a -3. The lowest common multiple is 6. You need 3 2's to get to 6. You need 2 3's to get to 6. Okay? And again, I'll let you do that more later. So now go back to your periodic table. Remember, we were skipping around the transition metals before. And it's because the transition metals can have different numbers valence electrons, okay? So they would have different amounts of, or they'd have different charges depending on how many valence electrons they have. So that is why when we were writing in our charges and our valence electrons on our periodic table from the previous video, we did not write anything up here. Remember, you had everything else written above these other groups that I have in white, but nothing above here. Now on your test, I will only ever ask you about iron, cobalt, nickel, and copper. I'll only ask you about these four, okay? And those four are found right here on your periodic table. You are going to need Roman numerals for your transition metals. So maybe give yourself a reminder, like I'm going to need Roman numerals for my transition metals. You can give yourself that reminder on your periodic table. That is totally fine. Zinc, however, if you look down here, zinc and silver always have a certain charge. So you could put this on the back of your periodic table, or you could just put them right in the little boxes. So zinc is right here if you want to put a +2 in there. And silver is kitty corner from it, and it's a +1. You can put those in the boxes as well. Okay? So what this means, how this is going to happen, to find the charge that you're going to use of the transition metal, you're going to look at the charge of the opposite ion. So this one, this is named copper oxide, okay? Because Cu is copper, oxygen is oxide. But when we're naming these, they have actually the transition metals, in between the two names, they get a Roman numeral. And that is because copper can have different amounts of valence electrons, so it can have different charges. So we need to figure out what is the charge of copper. And we know the charge of copper because you can look at oxygen. Oxygen has a -2 charge. So remember, charges have to balance out. So if oxygen has a -2 charge right here, that means copper had to be a +2 charge in order to cancel out. So this is copper 2 oxide. That is the proper name for it, okay? Now the next one is iron, because that's the name. So iron. Chlorine would change to chloride. But you just gave yourself that reminder in your periodic table, and you're like, oh yeah, there's iron. It's transition metal. I'm going to need a Roman numeral in the middle. It kind of has like a middle initial. Now chlorine is a -1 charge, but there's 3 of them. So there's a total of a -3. So the total of a -3 charge. That means iron has to be a +3 charge, all right? Same sort of thing here with copper and sulfide. Copper, oh, copper is a, oh, oops. And sulfur is sulfide. Sulfur is a -2 charge, okay? So you would think, oh, copper has to be a positive charge, but look down here, copper, there is 2 of them. So 2 coppers, each one actually has to be a +1 charge because there's 2 of them. So if each one of these is a +1 charge, it averages out to a +2, and then that'll cancel out your -2. So this is copper 1 sulfide. Okay, then we're going to do the names here real quick. So the same sort of thing we're going to do with the formulas. So this is copper, Cu, sulfide is an S. Copper is a +2 because it says so right there. Sulfide is sulfur. It's a -2 from my periodic table. I'm good. It's just Cus. Iron is Fe from my periodic table. Its charge is a +3, so I'm going to put that off to the side. Chlorine's a -1. It's Cl. Lowest common multiples between 1 and 3 is 3. I need 1 iron, but remember I don't put the number 1 as a subscript. I need 3 chlorines to get to a -3, so it's just FeCl3. All right, so there are some practice problems. If you would like to try those, I will put the key on the Google Classroom as well, so you can give that a try where I have this posted. The next thing we're going to talk about is polyatomic ions, but I only have about 30 seconds left in this video, so I will make a new one that'll be really short to just talk about polyatomics really briefly. Thanks.